number 5, we need to find a power series representation for the following function using differentiation, and in this case, anti-differentiation. So what we want to do is first consider what in this function kind of looks like any of the power series that we know. And what you want to do first is you want to separate the x to the 4th from the rest of it, because x to the 4th is something we could always multiply in afterwards. So we have x to the 4th times 1 over x plus 2 squared. Now, x plus 2 squared on the denominator is very similar to one of our power series. And the power series I'm referencing is we know that if you have 1 over 1 minus x, that we have the sum from n equals 0 to infinity, x to the n, where our interval of convergence is -1 to 1. So what we want to do is try to see how we could get 1 over x plus 2 out of this. So instead of having 1 over 1 minus x, we need to have 1 over 1 minus something that when you distributed it all, it would give us x plus 2. So in order to have 2, we already have 1, we would need to add 1. But we're subtracting, so we have to do minus 1. And we need to have a positive x down there, so we need to have minus x. So if you distributed this, you would get x plus 2. So now that series representation is the same as the above, except everywhere there's an x, we would replace it by -1 minus x. So now we know that -1 minus x has to be in between -1 to 1. So, again, this is equal to 1 over x plus 2. So we have x plus 2 squared, which means this, we're going to be needing to take the derivative of that. So, what we need to be careful about, though, is whether this changes the sign to positive or negative. So, when we take the derivative of 1 over x plus 2, so let me write that down here as x plus 2 to the -1. So what happens when we take the derivative of that? When we do d dx of that, what we get is we get -1 x plus 2 to the -2. And we don't have to multiply by anything because of chain rule, because x plus 2 has a derivative of 1. Written as a fraction, we get -1 over x plus 2 squared. So when we take the derivative of this, we're going to get the negative of what we want. So to get what we want, we just have to do the negative of that. So by doing the derivative here of this series, what we're going to get, so by doing the derivative here, all we have to do is put the n in front and do our normal way of doing the derivative, -1 minus x to the n minus 1. However, our derivative of the inside is -1, so we do have to multiply by that with the same interval as above. So, that's the derivative of 1 over x plus 2, which, like we said, is equal to -1 over x plus 2 squared. We just want 1 over x plus 2 squared, so we want to take the negative of this. Since it already has a negative sign, then we just kill that. So the last thing we need to do is we need to multiply. So now here we get 1 over x plus 2 quantity squared is equal to the power series. Now we don't need to start at 0 because we have, that would just be 0. N equals 1 to infinity of n minus 1 minus x to the n minus 1. So in order to get what we want now, all we need to do is multiply that by x to the 4th. So therefore, x to the 4th over x plus 2 squared is equal to our same sum. So what we can do here is we can do a little bit of simplification. This, we could factor out a negative and therefore make this alternating. So we could have n -1 to the n minus 1 times x plus 1. Now that we've taken out the negative, this would be x plus 1. to the n minus 1, and we're multiplying by x to the 4th. So the last thing we need to do is just consider what is our interval in terms of x. Because we know what our interval is, but we know that -1 minus x has to be in that interval. So let's just get it in terms of x by itself. So here, what we need to do is figure out, we know that -1 minus x has to be in between -1 and 1. So let's just solve for x. So what we're going to do is we're going to add 1 to both sides. So we get -x is in between 0 and 2, and then we have to flip it because we're dividing by negative. So we get x, now this is just written backwards, but it's basically the same thing. X is in between -2 to 0. So our final answer here is the sum we have written over there, which I'll just rewrite here. So we have, let me write the alternating part first, because that's how it would normally be written. We have n x to the 4th times x plus 1 to the n minus 1. And we know that our interval now, we have to be between -2 and 0. So we can say that x is in between -2 and 0. And that's our interval. So remember that when you write the representation of a function as a power series, the interval is part of the answer. So you always have to have that also. So that's our power series with that corresponding interval.